Welcome back. This is number 7 from Homework 24. Once again, step 1 is clear the fractions. How do we do that? In this case, we're going to multiply by the greatest common denominator of x times x minus 3. So let's do that carefully and see what the outcome is. Because this is not a quadratic equation at the moment, is it? Okay, there's the setup. When we multiply this first term, we get this nice cancellation of the denominator, and I get 12x. When I look at the second term, what cancels? The x. So I'm left with 8 times x minus 3. And over here, I have 14x times x minus 3. Very similar to the previous problem, but let's be careful. This will be 8x. We have 8 times negative 3, that's minus 24. This equals 14x squared minus 3 times 14 is 2x. All right. Now, I don't want to move this to that side because then it will become negative. So what I'm going to do is first combine these two. I have 12 and 8, which makes 20x minus 24 equals 14x minus 42x. Now, I don't want to confuse you here, but I don't want to subtract this from both sides. I don't want to have a negative 14x squared. So I just kind of switch the order, flip-flop these around. This is an equal sign. We can do this. That's a legal move. This is equal to that, so that's equal to this. So I just change the order. And now I see what I need to do. I need to subtract 20x, and I need to add 24 to both sides. And now I will get my quadratic equation. 14x squared minus 62x plus 24 equals 0. And now we need a little more room. So let's get a new page. And okay, so the first thing I might say is, why don't we go ahead and divide everything by 2? We can divide this side by 2 and this side by 2. And that's going to give me my quadratic equation. 7x squared minus 31x plus 12 equals 0. Okay, now, what do you want to do? This is up to you now. I would not complete the square. I would use the quadratic, maybe, or maybe I'll try to factor it. If it factors, what do we need? We need A and B such that A times B equals 7 times 12, which, if I remember correctly, is 84. Is that right? I better double check. Yes. And A plus B equals negative 31. Well, this is not so easy to do, is it? Let's see. Um, do you want to use the quadratic formula or not? Let's see if we can do it. 84. What are some factors of 84? Well, let's see. Sometimes I do this. Does 1 divide 84? Of course. 1. 2 divides 84. 3 divides 84. 84 divided by 3 is 28. And already I have stumbled upon a pair of numbers that are going to work. 84 is 28 times 3. It's also negative 28 times negative 3, isn't it? And negative 28 plus negative 3 equals negative 31. So we can factor by grouping. All right, how does this go? We rewrite 7x squared minus 28x minus 3x plus 12 equals 0. Group. This is sort of a good review. What can we factor out from this first group? Here, we can factor out 7x. What does that leave? X minus 4. What can we factor out here? You might say 3, but we're really factoring out negative 3. And that's going to leave x minus 4 as desired. Because remember, these two factors here have to be identical because our next step is to factor them out. So factor out x minus 4, and what's left here is 7x. What's left here is negative 3 equals 0. Wow. So x equals 4 or x equals 3 over 7. How about that? It factored. Now, what if you don't want to do factoring by grouping and you don't have to? You could have used the quadratic formula. A is 7, B is negative 31, C is 12. You could plug those all in and get the same answer. Or you could have completed the square, which would have been ugly. So my two choices here, I liked factoring because it wasn't that hard to do. But if you get stuck with the factoring, switch, do the quadratic formula. One more thing before we finish this problem, we need to check that we can put these back into the original problem. We know that x cannot equal 3 and x cannot equal 0. So keep in mind that our original problem had x in the denominator, and you always have to be aware that those numbers are not allowed as solutions. Our first word problem, number 8, and these are technically going to be whole numbers. So it's not a very difficult word problem to understand, except for this word. This is very important. We know that they're two numbers. You might try to call them M and N, but we don't want to do that. These are consecutive numbers. So let's do this. Let n be the first number. What does consecutive mean? Consecutive means one after the other. This would be like 2 and 3 or 5 and 6. They're consecutive. So if n is the first number, then here's the whole key to the problem. Then n plus 1 is the consecutive number, the next number. Now, that is half the battle right there. So please let this be a problem that you can solve. Now, we know something else. The sum of their squares is 113. What does that mean? It means if we square both of these numbers, it equals 113. That's the key. Now, all we have to do is multiply this out and solve. So what do we get? N squared plus, surely you can do this by now, n squared plus 2n plus 1 equals 113, or 2n squared plus 2n equals, let's see, what do we want to do? Let's just write plus 1. Don't do too many things at once, because that's how you make mistakes. Now, what do we need to do? We want to subtract 113 from both sides and get 0 on one side. And this will be our quadratic equation to solve. 2n squared plus 2n minus 112 equals 0. So what's the first thing you're going to do now? I hope it's divide everything by 2, because that will make your life much easier. So I have n squared plus n minus 56 equals 0. And this factors really easily. This is n and n. Isn't 56 7 times 8? So one of these is 7. One of them's 8. One of them needs to be negative. That's going to be the 7. Now double check that that works out for you. I can see that it does. Now, here's a slight hiccup. Which one of these is the answer? Well, we want a whole number. So this is the whole number. So that's n. So what is n plus 1? N equals 7, and n plus 1 equals 8. So my two numbers are 7 and 8. And if you square those and check, that would be 49 plus 64, and that does equal 113. Okay, we're going to take another break here, and then we'll come back for the last two problems.